Grade 8 Math number 8.1b, Parallel Lines and Systems of Equations. So as we said in the last video, a system of equations is a set of two or more equations that have the same variables in them. And a solution of a system of equations is an ordered pair that satisfies all the equations in the system at the same time simultaneously. So we can solve a system of equations by graphing. We find the ordered pair at the point where the graph of the equations intersect, where the lines intersect. So if we graph the equations, and this is one equation and that's another equation, and where they cross each other, right at that point where they intersect, where they crisscross, that is the solution of the equations. That would be the xy coordinate, the ordered pair, that would be able to solve the equations. Okay, the system of equations. So we said before that we've learned several ways to graph an equation in slope-intercept form, and we can use the slope and y-intercept, or we can find 2 points that satisfy the equation for x and y and connect them with a line. But what if the lines are drawn and they don't have an intersection? What if the lines are parallel? Well, then there's no solution because they never intersect. There's no xy to use to solve the system of equations. So look at these two equations right here. We can see that the y-intercept for this one is a -8. So -8 is way down here. So you can tell I made a box around it. This is the blue line. That's the pink line because of the box around it. So the blue one has a y-intercept of a -8. So we put that point for the -8 way down here. That's the y-intercept. And it had a positive slope of 2. So we know it's going up in this direction, okay? And how do we do a slope of 2? Well, it's a 2 over a 1. It's the rise over the run, right? So we're going to go up 2, 1, 2, and run over 1. So that's our other point. We draw a line through it, and that's our blue line. So now for this one, we've got a -2 for our y-intercept B, okay, for the pink one. So there's -2 for our y-intercept B. And we've got another positive 2 slope, so that's a 2 over 1. So we go up 1, 2, and over 1. And because it's a positive slope, it's also going this way. And then when we graph it and when we draw the lines, look what happens. We connected the points. We ended up with 2 parallel lines. They don't intersect anywhere. So there's no crisscross. There's no point. There's no xy where they meet, where they intersect to be able to plug in as the x and y values. We can't do it. See? They never intersect. All right. What happens when they do intersect? Okay, as we showed in the last video, an ordered pair, x and y, is a solution of a system of equations. If it is a solution of every equation in the set. So, we've got this equation, the blue line, and this equation is our pink one. So let's take a look at this blue one. We know that this -4 is our y-intercept B, okay? And this is written in slope-intercept form, okay? So that's the y value in the xy coordinate. That's the slope. That's the x value in the xy coordinate, and that's our y-intercept, okay? That's where it's going to hit the y-axis. So we know this -4, this red 4, is going to hit the y-axis line at -4. That's the blue line, okay? So we hit it right here. This is the y-axis line, and here's that -4 right there, okay? We can also see that it's got a negative slope of -2. Remember, negative slope means it's going to fall to the right, right? Our line's going to be like that. So we're going to go down 1, 2 for our rise and over 1 for our run, okay? So our little L shape is going to be down 2, 1, 2, and then over by 1. We can rewrite the slope as the rise over the run because -2 over 1 is the same thing as -2, right? So we know what our rise over our run is. So we're going to go down 2 and that way 1 because it's a negative slope and our line has to go that way. So we were at -4 for our y-intercept. We're going to go down 1, 2, and run over 1. So the rise was down, negative, and the run was over 1. See? So that's our point, okay? We're at a 1 and a -6. See that? That's our ordered pair, 1, -6 for that point. Okay? So, ignore this point right here. So for the blue line, we've got this point and this point from the equation, and we drew a line through it, okay? And it was this line. So now, let's look at what happens for the next equation, the pink one, okay? So our y-intercept is a +1, so that's where it's going to hit the y-axis, okay? So that's right here, that's +1, okay? And it's got a positive slope of a 3. So the rise over the run would be 3 over 1, because 3 over 1 is just a fraction. It means 3, right? So we can rewrite it as the rise over the run. It's still a 3. So we know to go up 3 and over 1. Now, because it's a positive slope, we know it's going to go this way, right? Remember, positive slope rises to the right, negative falls to the right. So our line is going to go in this direction, okay? All right, so we know that it's got to hit at the +1 on the y-axis. That's right here. And now we're going to go up 3. 1, 2, 3. And our run is a 1. So it's going to go over 1. See that? So we went 1, 2, 3 for our rise. And our run is over 1. And that puts us right here. Okay? So now we've got this point and this point. We draw a line through it. And the blue line and the pink line crisscross and intersect right there. See? This point is, for the x, it's a -1. And for the y, it's a -2. And that's our ordered pair, -1, -2. Now what happens if we plug this into both equations? Will it be a solution for both equations? We'll check this out. So, our y is going to be a -2, all right? So that y is going to be a -2. We know the slope was -2, right? Our x is a -1, so -2 times -1 is going to be a +2, because 2 negatives make a positive. We drop down our -4. 2 take away 4 is -2. -2 equals -2. Yeah, it worked for that one. All right, let's plug it into this one. So now we've got, this is our y. The -2 is equal to 3, that's our slope, times the x, -1, plus that 1. Well, 3 times -1 is -3. -3 plus 1 is -2. -2 equals -2. Look at that. Yes, it's a solution for both equations. -1 as x and -2 as y is a solution for the system of equations. See that? But we needed it to intersect, didn't we? We needed it to cross to get those x and y coordinates, the ordered pair, to be able to solve these equations. This one, they'd never met. They never had an ordered pair where they intersected to be able to solve that. See? Because they were parallel. All right? So that's parallel lines with a system of equations. Okay? I'm going to continue talking about graphing systems of equations, and I'll see you in 8.1c. All right? Keep your chin up. We're making it. All right? See you next video. Bye.